Yeah, I don't remember ever having any problems with you on this, as opposed to my last student who got locked off halfway through the session and she couldn't get back on. So what do we
Oh,
got tonight? You got problems, stuff you can verbalize? I got to go at
oh,
5:30.
I sent you an email with some problems.
Okay, let me open it up here. Did not get, yeah, it did. There it is. Download that. Pop it open. Looks like I need to rotate it twice. All right, so we're looking at conic sections still here.
Yeah.
All right, let's see. Let me zoom down a little bit so I can, oh man, sometimes I hate Windows 10.
Yeah.
I really do. I hate it with a passion.
Uh-huh.
It, sometimes I can move these pictures and sometimes I can't. I never
Uh,
figured out why. Yeah, so
yeah.
I
Huh.
can move it now and get to the problem. Okay, which one do we want to start with? Number one?
Oh, we could just yeah. Let's start on number one.
Okay. So first of all, let's just go through a little exercise. You tell me what each of these things are. What's number one? Parabola,
Um.
circle, ellipse, or hyperbola?
Oh, I think. Well, I was kind of thinking maybe parabola.
Correct. Horizontal or vertical?
Um.
Remember what the typical vertical parabola looks like. It's y equals x squared, right?
Yeah. So would it be
This one is x equal y squared.
Okay.
So this has to be a
Then
horizontal one.
okay.
Okay. Let's just look at number two. What kind of figure is this?
Um. I wasn't too sure, but I was thinking it could be
Can only be a,
uh a hyperbola.
no, it's a circle. In other
Oh, a
words,
circle.
it's x squared plus y squared. That makes it either a circle or an ellipse.
Okay.
And the fact that they both have the same coefficients makes it a circle.
Okay.
Okay.
Yeah.
Let's look at number three. That also has an x squared plus y squared, but different coefficients.
Well then, could it be an ellipse?
That's definitely an ellipse. Now let's look at number four. We'll go back and do these. I'm not trying to not do them. I just want to get you to a point where you can recognize what it is just by the polynomial.
Okay.
Okay. Number four, notice that there's subtraction going on between the x and the y squareds.
Yeah.
That's hyperbola.
Okay. Okay. Yeah, that makes sense.
And that's a vertical hyperbola. If it's x
Okay.
squared minus y squared, that's a horizontal hyperbola.
Mhm.
If it's y squared minus x squared, it's a vertical hyperbola.
Okay.
That's the difference. Number five, what is that?
Um. Um. Is it a like a circle?
Yep, it's got the plus sign between the x squared and the y squared.
Okay.
Makes it either a circle or an ellipse automatically.
Okay.
And the coefficients are the same. They're both 1. That makes it a circle.
Okay.
Number 6.
Um. Hyperbola.
Number 7. And what kind of hyperbola? Horizontal or vertical?
Um. Is it going to be vertical?
Horizontal.
Okay.
If it's x squared minus y squared, it's horizontal. If it's the reverse, if it's y squared
Okay.
minus x squared, it's vertical.
Okay.
It's number 7.
Um. It's going to be in an ellipse.
Good. Number 8.
Um. That's going to be a hyperbola.
And it's horizontal.
Yeah.
Okay. On number 7, I don't immediately know whether that's vertical or horizontal ellipse, because it could be either.
Yeah.
We have to put it in its standard format before we can figure out which has the greater denominator.
Yeah.
Then we'll know
Yeah.
whether it's horizontal or vertical. As long as it's in a polynomial format like this, it's not easy to tell whether it's horizontal or vertical ellipse.
Yeah.
Not true with hyperbolas. You can immediately tell whether they're horizontal or vertical depending on where the negative sign is in front of.
Okay.
And number 9, what's that?
Um. Parabola.
Parabola, vertical or horizontal? You can tell by looking at this.
Is it vertical?
Yeah, because it's y equal x squared.
Okay.
Okay? That's the traditional parabola you've dealt with for 3 years. Remember that, because you know the traditional parabola is always vertical. Might go up,
Okay.
might go down, but it's vertical. Whereas
Okay.
horizontal parabolas have to be x equal y squared. In other words, I would need a y squared term and only an x term for it to be a horizontal parabola.
Okay.
Finally, 10, what's 10? You can tell instantly from the first 2 terms.
Oh, it's an ellipse.
Okay, we don't know which way it goes yet.
Yeah.
Now let's go back. What we have to do on all of these is put it in the general format.
Yeah. The standard form.
Now, when you take your final, do they give you a sheet that has all the general formats, or do they want you to memorize all those?
I think they want. I wasn't sure, but I don't think we're allowed a sheet, so we'll probably have to memorize them.
Okay, there's a lot to memorize here.
Yeah.
First
Yeah.
of
I was gonna
all,
go.
well, let me give you the general format for this parabola. And remember, this is
Okay.
a horizontal parabola because it's x
Yeah.
equal y squared. So
Okay.
for a horizontal parabola, do you use the 4p notation?
Yeah.
Okay, that goes in front of the term that is not being squared. And on the other side, you have the term that is being squared. H always goes with x, y always goes with k.
Okay.
There's your format.
Okay. And what about the P? What
That's
is
the
that supposed?
focus. That's the
Okay.
focal length.
Okay.
Okay, so once we get it into this format, let's do it. Let's start with what we got here. So I've got just a single x, so I'm going to move that x to the other side. And here's what I'm going to do. Y squared plus 6y, put parentheses around that because I'm going to be completing the square.
Yeah.
And on the other side, let me think for a moment here. We'll leave the 17 there for a moment.
Okay.
And we'll put the 8x, oh no, uh, minus 17. We can do that.
Okay. We can do that to both sides.
As long as I don't change it. In other words, my goal is to never change the original equation. Is this row the same as the equation they gave us?
Yeah.
Yeah, it's exactly the same. So all I've done is move 2 terms to the other side.
Okay.
Now complete the square inside the parentheses.
Okay. So we'll take the 6, divide it by 2, and then square it.
Okay.
So we're left with 9.
Plus 9.
Why?
I need the
Yeah,
plus.
plus 9.
I need the
And
plus
then
because it's part of the
and we also we do that to the other side as well, right?
right. In other words, I add 9 to the other side to balance it out. Because,
Yeah.
again, I don't want to change anything. In other words, this is now still exactly the same as what we started with. So
Okay.
all I'm doing is rearranging it. I'm rearranging it such that I can get it into this format, only I've put the y term on the left and the x term on the right. That doesn't matter. You know what I mean?
Yeah.
Okay. So now how can I write this left side of the equation?
Well, you can do it y plus 3 squared.
Correct. Now I'm getting closer to my format. And what's on the right side?
8x minus 8.
Okay. Now factor, take a greatest common factor.
Um, it could be 8 times x minus 1.
Okay. Now we're getting closer. Now divide both sides by 8. You get 1/8 over here, and it gets rid of the 8 on the right side.
Okay.
Now we've got it in exactly the format we needed.
Okay.
Excuse me, leave that 8 over there. I apologize. I confused myself by switching these two terms. The only reason I switched it is because it'll make the 8x positive if I put it on the right side. Okay?
Okay.
So this is correct. Actually, that's in that format, right?
Okay.
What's
And then
H and K?
um k is 3 and h is
K is
1.
negative 3 because it's
Oh
1
yeah, k is
minus,
negative 3.
and H
And
is 1.
h is 1, yeah.
And what is P?
Uh p would that be 8?
4P is 8.
Oh, so it would be 2 then, right?
Yeah. In other words, we've got it in the exact format, so there's our 4P. Whatever's in front of the linear term, the x term, that's 4P. Whatever that number
Okay.
is 4P. And that makes
Okay.
2.
Okay.
Okay. What else did they
And
want?
then they also, well, if it's a parabola, they want the directrix and the latus rectum.
Okay. Love these math terms. Whole,
Yeah.
whole class must bust a gut when he says that.
Yeah.
All right. So let's draw it. We know our vertex is at 1 minus 3, right?
Yeah.
And we also know that it's a parabola horizontal, which opens which way, right or left?
It's going to be opening
To the right
uh,
is the same as up. In other words, if the y squared term has a plus sign in front of it, it opens to the right. If the y
okay.
squared term has a negative sign in front of it, it opens to the left. So I
Okay.
immediately know this opens to the right like this. Okay? The focus is 2. What that means is that that distance is 2. So what are the coordinates of the focus? If it's 2 units to the
Okay.
right of the vertex, what are the coordinates of the focus? Still there, Peyton? You kidding? I lost another one? Peyton, you there? Wow. Peyton, you there? Hmm. 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 Huh? You're back. Peyton, hold on. Give it a second. I gotta wait for the audio to come back. Yeah, Peyton?
Yeah, sorry about that. I got disconnected.
Okay, that's what happened to my last student last half hour, exactly about the same point in time. Do you know how you got disconnected?
Oh, well, like my audio got like shut down, like turned off.
Okay, so just something on your end, you're sure?
Yeah.
And now you're back on? You can still see my screen? What number did I just write?
Yeah, I can see you. Yeah, I can see your screen. I just my audio's still like getting like.
Well, we can do the audio by phone, but it's really important you see my screen. What number did I just write?
7.
Okay, good. We can finish the session using the audio from our phones.
Okay. Yeah.
That's no big deal, but you have to be able to see my screen. So let me minimize my GoToMeeting so I can see. So back to this question, what are the coordinates of the focus if it's 2 units to the right of the vertex?
It's going to be 3, -3.
Correct. 3, -3.
Yeah.
So that's where your focus is. And the directrix is always perpendicular line to the axis of symmetry.
Okay.
And it's always the same distance away from the vertex as the focus is. So the directrix is 2 units to the left of the vertex. What's the equation? And the directrix is a straight line, so you need the equation of a line. What's the equation of this directrix?
It's going to be x equals -1.
Correct. Okay. Now, the latus rectum, which is also called the focal width, that's the new modern terminology for it, is 4 times the focus, always. It's 4 times the focal length. So LR is 8. And what that means is the distance from there to there. That's what latus rectum means. That's what focal width means. Is you draw a line parallel to the directrix going through the focus and the length of that line.
Okay.
Is that all they ask for on this one?
Yeah, that's all they ask for parabola.
Okay.
And the vertex, the directrix, the focus, the latus rectum.
Okay. Now, let's try to get in one more here. Hopefully we'll be able to. Should we do a circle?
Yeah, sure.
Or an ellipse? Circles are pretty easy. You know how to complete the square. Do you know the general format for a circle?
Yeah, I do.
What is it?
H minus H plus.
Hold on.
No, X minus H.
Squared.
Times Y minus K.
Plus.
Oh, plus Y minus K.
Squared.
Yeah.
Equals R squared.
Yeah.
Okay. Now, I don't think you can see my screen anymore because it looked like you got kicked out again. But
no, I can still see it.
Well, you might be seeing it, but I don't think you're seeing it in real time. What number did I just write at the bottom of my screen?
Oh, you just wrote 8.
Oh, you are seeing it. Okay. Okay, good. We can finish the audio over the phone, no problem. So this number 2 is a circle. Do you see how you're going to get it into this format?
Yeah.
Yeah, you're just going to put your x's together, your y's together. You're going to complete the square. You're going to put the 11 on the other side. For every number you complete the square in, you got to, you know what, we better do this one because there's a little extra kink here that you have to be a little careful with. So let me do the first part, which is this part here, combining those, and then it's plus 4y squared plus 16y I'm going to move the 11 over to the other side. You with me?
Yeah.
Now,
Okay.
now let's get this thing into this format. So before you can complete the square, you have to do something, which is what?
So you're going to have to factor it out.
You always have to have this coefficient be 1 before you can complete the square. So you're dividing everything by 4, and it doesn't matter. That could be an 11. You'd still divide it by 4. In other words, it doesn't have to divide evenly. In this case, it does divide evenly, but it wouldn't have to. You just got to get rid of that 4. So this becomes 4 times x squared minus 3x. I'm going to leave room to complete the square. Plus, got to do the same thing over here. Factor out the 4, leaving y squared plus 4y. Leave enough room to complete the square. It's all equal to 11. Now, complete the square here. And whenever you complete the square, it's always added. Always.
Okay. So with the 3, you'll have to divide it by 2 and then square it, so you'll get plus 9.
Plus 9/4.
Yeah.
Because 3/2 is what you get when you divide it by 2. And when you square 3/2, you get 9/4.
Okay.
How much do I have to write on the other side of the equation to balance it?
Yeah.
How much?
You add 9/4 to the other side.
Nope. That's what was tricky about this. That's why I wanted to go over it.
Okay.
When I wrote 9/4 in there, how much did I add to the left side of the equation?
You multiply by the 4.
Right.
And then you add it. So would it be wouldn't you get 9?
Yeah. So I balanced this thing out by writing over here plus 9.
Okay.
What in the world? The technological gods are going crazy here. My writing pad just messed up. So bear with me here without me writing. So I'm going to add 9 to the right. Also?
Yeah.
Now, how do I complete the square with the y term?
It will be 4y squared plus 4y plus 4.
Okay. How much more do I add on the right side?
If you're going to multiply that 4, you're going to add 16.
Okay. So the right side is now 36.
Yeah.
Okay.
And that's r squared. So if you want to find r, you have to square root it.
Well, we also want to get rid of this 4s. In other words, we now have 36 on the right side of the equation, but we want to divide everything by 4, making the right side of the equation 9.
Okay.
So now here's what we have. See if you can picture this, because I can't write it. I'm going to have to reboot my drawing tablet. So here's what the left side says. X minus 3/2 quantity squared plus y plus 2 quantity squared equals 9.
Okay.
That gives you the center of your circle, and it gives you the radius is going to be what?
The radius is going to be 3.
That's the only 2 important things about a circle. It's so much easier than ellipses and hyperbolas and parabolas. It isn't funny because there's no foci. It's just where is the center and what is its radius. Okay? And that's why you don't want these coefficients of 4 over here, is because I need the left side to be in the format of the top line. It's got to look like x minus h squared, not 4 times x minus h squared.
Okay.
So you get rid of the 2 4s by dividing both sides of the equation by 4. And that's what turned that 36 into a 9. Then you have it in the perfect format of the circle, and you can go from there.
Okay.
And that's pretty much the way you're going to do all of these problems. but every one of them depends on you knowing the precise format, the general format of each of these figures. That's why I started off our session by going through all 10 problems so that you knew how to know what kind of figure it was.
Yeah.
Because you can't put the general format down until you know what kind of figure it is.
Yeah.
Now there's one couple things extra that I'll just add real quick here.
Okay.
For ellipses, A always has to be bigger than B.
Okay.
A can come under the y term, doesn't always have to be under the x term, but it has to be the bigger denominator.
Okay.
If it's under the y term, you have a vertical ellipse. If it's under the x term, you have a horizontal ellipse.
Okay.
Okay?
Okay, I'll write that down.
Okay. With a hyperbola, that's not true at all. A doesn't have to be bigger than B. B could be bigger than A. A always goes under the major transverse axis variable for a hyperbola.
Okay.
So if you have a vertical hyperbola, A is going to come under the y term. If you have a horizontal hyperbola, A will be under the x term.
Okay.
And A and B can be anything relative to one another. That's the dimensions of that rectangle that you draw, the imaginary rectangle. And A is the measurement along the major. You know when I say the major transverse axis, how you get that with a hyperbola?
What?
The major transverse axis for a hyperbola is if you connect the two vertices, you get it.
Okay.
In other words, if it's a horizontal, then if you connect the two vertices, you have a horizontal line. If it's a vertical hyperbola and you connect the two vertices, you got a vertical line. And A is always with the major transverse axis. It's always measured on that axis, depending on which it is.
Okay, yeah, sounds good.
All right, Peyton. I will let you go and talk to you next time. We have a Friday session, I believe.
Okay, yeah.
No, hold it. Excuse me. It's not Friday. It is Sunday at 6.
Okay.
Talk to you then.
Okay, wait, actually, just wait, one more thing. Do you have like another session after this?
I do.
You do?
I do. I have a 5:30.
Okay,
I'm
yeah.
2 minutes late to right now.
Sorry, I think my mom wanted to talk to you about something, but I wasn't really sure what it was.
Okay. Have her call me. You have my phone number?
Yeah, I do. I'll call you.
In 30 minutes, I'll have an hour break.
Okay.
So if she wants to call me between 6 and 7 tonight, I'll be here.
Okay, yeah, sounds good.
All right. Bye-bye.